We're going to be talking about methods of sealing the pump. This is the impeller shaft inside of a pump body. You'd have an impeller or two impellers pressed into the middle of the shaft, and it's located inside the pump body just like that. This part of the shaft extends out the back side of the pump, engaging with the pump transmission. The front side will engage with an outboard bearing to support it on the other end. We do need to seal the shaft though as it enters into the pump body and exits out the other side. We're going to use two different methods to seal this pump. We're going to use packing and mechanical seals. The first method we're going to talk about is packing. Packing is a braided material which is going to be used in the stuffing box area. As I mentioned, impeller shaft goes in, you have impeller or impellers in the middle of the pump, and then you have an outboard bearing. We do have two areas where that shaft enters and exits the pump body called the stuffing boxes. There's one here on this end and one over on the outboard side of the pump. We're going to seal the impeller shaft with what's called packing. It's braided material. This is braided flexible graphite. It's a graphite material with threads of graphite yarn woven into it. And it's flexible so it can go around the impeller shaft. We're going to put this around the shaft, stack the pieces up, stagger the joints by 90 degrees, and we're going to compress that packing to seal it off. The packing goes into the stuffing box. This is a seal housing used in a post-93 body style. The stuffing box is part of that seal housing. The shaft goes into that seal housing, into the stuffing box. We have the four pieces of packing that would be inside there. On the end of the stuffing box area, you've got two stainless steel studs. We have what are called packing glands. On either side, it's a split gland, so there's a piece like this. There's one on either side of the stainless steel studs. The shoulder on the packing gland goes into the stuffing box, and it compresses the packing. And then we use a washer and a nut on those studs to tighten the gland down. Okay. So we push the packing into the seal housing. One of the things inside the stuffing box is called a lantern ring. Right? So we have the gland going in, four pieces of packing. Lantern ring is the base. The lantern ring is a ring that's concave on the outside, has holes drilled through it. There's a cooling line that comes up on the bottom of the seal housing. So there is a passageway that water comes up. The first stage of a two-stage pump off a CM pump comes off the first stage. On a single stage, the CS pump, it comes off of both sides of the dual suction eye impeller. But we cool it off the first stage side of the pump on a two-stage pump. But it comes horizontal, vertical, comes up to that hole. That hole lines up with the lantern ring. So the pressure comes up, pressurizes around the lantern ring, and goes through holes that are drilled through the lantern ring to the interface of the packing and the impeller shaft. The water then pressurizes down past the packing and the shaft, cools it, and then drips out of the arrangement. The drip rate on a properly adjusted packing, running at 150 psi, recirculating water. You do have to be moving water to check your drip rate. At 150 psi, moving water, drip rate should be between 10 and 120 drops a minute out of this packing. We need to have the water dripping out of this area or leaking from this area to make sure we have water between the impeller shaft and the packing to cool it. The second way to seal the pump is mechanical seal. Now, mechanical seals are designed not to leak. Static, running, doesn't matter. Mechanical seal does not leak. It goes into the same area as far as you do have seal housings, just like the packing style, but they're a little bit different as far as the stuffing box area is a little bit bigger, more water flow and stuff in that area to help cool the interface again.
We do have to cool this area again to keep the mechanical seal from overheating. The cooling water comes through the same cooling lines we use for the packed pump, but the water is directed back to the impeller eye area, low pressure, through the hole in the seal housing.
So there's again, one on either side of the pump. The impeller shaft comes in from the chain case, you have your impeller or impellers, another seal housing, and then your outboard bearing. Okay.
The mechanical seal consists of four basic parts. The first three, you've got a stainless steel spring retainer, a stainless steel spring, and the bellows assembly. These items will rotate with the impeller shaft to create your seal. The bellows assembly has a rubber sleeve on the ID and a polished carbon ring on one end. The polished carbon ring is the sealing surface, or the primary ring. The fourth part of the seal assembly is the stationary ring. The stationary ring is silicon carbide. You have a polished surface on one side, an unfinished side on the back, and you have an O-ring around the OD. When assembled into the stuffing box area, this will create your seal to keep water from leaking out of the pump and air from coming in when you're drafting.
So the way it works is the inside bellows, again the rubber portion, it's going to stick to the impeller shaft after we assemble it in a certain location to compress that carbon ring up against the stationary ring. So that rubber is actually too small for the impeller shaft. I tried to slide this and seal over the end of the impeller shaft and over this diameter, it won't fit over it. Okay? The ID of the bellows assembly is a little bit smaller than the OD of the impeller shaft. So it doesn't want to slide onto it. Besides that, it is rubber and it'll want to stick. So we have to use a lubricant that basically makes it very slippery. We squirt that all over the impeller shaft, all over the bellows assembly, back inside the stuffing box, and that will allow the bellows assembly to slide over the impeller shaft. Okay. So the spring retainer goes up against the shoulder on the impeller shaft. That keeps the spring and spring retainer from hitting the back of the stuffing box. So in your bellows assembly, you put lubricant in the inside of that, and you'll slide that over the end of the impeller shaft. Okay. And then you'll bring your stationary ring, which is the silicon carbide stationary ring. That gets installed into a chamber cover. Right. So we put the lubricant all over the bellows assembly, all over the impeller shaft. We slide this over the impeller shaft back inside the stuffing box. We push it in firmly and evenly, kind of walking it as it goes back inside the stuffing box. And it'll pop back out just like the picture there on the bottom right shows. You bring your new stationary ring and your chamber cover over the end of the impeller shaft. And then when you push this back inside, it compresses the spring, pushes the bellows assembly back inside the stuffing box. And then after a time that lubricant dries up, this sticks to the impeller shaft. Okay. So now when the impeller shaft rotates, this will turn with the impeller shaft. And that creates a seal between the carbon ring and the stationary ring. It creates a seal along the impeller shaft on the rubber bellows. Okay. There's a seal around the outside of the stationary ring where the O-ring is at inside the chamber cover. So that creates your seals. So the mechanical seal is designed not to leak. Running, static, doesn't matter. Okay. So two different ways to seal the pump off: mechanical seals and packing.